Hi everyone and welcome. Today I'm going to be talking about OSPF, Open Shortest Path First, and I've actually got a little challenge for us to walk through. As you can see on my screen, it's basically a single area. So what we're going to see is we're going to use the backbone area of area 0. And what this essentially means is we're going to keep all of these routers in the same area. The idea of the challenge is to get PC1 in order to ping PC3 and also to ping PC2 here in different networks. So if you haven't watched my previous videos, I'd really encourage you, if you are completely new to OSPF, go back and have a look at the 4 videos I created previously. But what I'm going to do is I'm going to try and focus on solving this particular challenge today. So essentially, just to bring you through what I've done so far, each of these routers are configured to a certain extent. So as you can see here, it's got an addressing table for router 1, router 2, router 3, and each of these IP address and subnet masks have been configured in advance, okay? Also, I can see that PC1, PC2, and PC3, they've also got relevant IP addresses configured. So what is the objective for this challenge, guys? The objective for this challenge is to essentially configure OSPF version 2 routing. So that's the IP version 4 routing protocol, okay? So we want to obviously get OR1, OR2, and OR3 communicating using these open shortest path first to allow them in order for them to communicate so that these networks, like for example PC1 and PC2 and PC3, can communicate with one another. We're also going to verify that it indeed works. So we'll do that by pinging and we'll do some simulations. And really then the background to this is, like I mentioned, it is a single area OSPF. We're not going to do multi-area. Okay, if you did want to learn about that, it's a little bit more advanced or a step forward. So today what we're going to do is, because we've only got a small number of routers, we're just going to keep it within the same area. So all of these routers will share routes with each other and they'll establish neighbor relationships with one another. So what are what's the context here? So we're actually going to configure, obviously, OSPF version 2 routing. We're going to configure it on router 1, router 2, and router 3. And you can see I do have some specific items that I need to perform. So in particular, what it's asking me to do is it's asking me to use a process ID for OSPF of 10 here for each of the routers. It's also asking me to configure a router ID for each of them, being in this case router 1, router 2, and router 3, having different router IDs. And it's also asking me to use the network address for each interface. So again, there's multiple ways to configure OSPF. In this particular case, guys, it's asking us to use the network address for each interface. So again, to use this to match, obviously, the interfaces in order to start advertising and to start receiving these OSPF messages and to enable other networks to basically pick up on various other networks around the network. Okay, so in order, when we turn on OSPF on OR1 and we turn it on OR3, we obviously want them two routers to start talking OSPF between each other, so sending these link state advertisements over to each other. What we want to be basically able to do is we want OR1 to be able to say, hey OR3, do you know about the 172.16.1.0 network? And OR3 will say, no, I didn't know about that, because OR3 would only know about its connected networks, which would be this network here, and this network here, and this network here. So it would basically say, oh, I'd very much like to know about this network that you're connected to. But again, it's not connected to me. It's across this wide area network, this serial link. So again, OR1 would communicate that to OR3 using what's called these link state advertisements. Now again, in order for this to happen, we've obviously got to configure OSPF. One last thing before we go into this, guys, just to mention, basically what we're going to need to do also is, as part of verifying the OSPF routing protocol, what it's asking us to do is it wants us to adapt or to change some of the cost of the links in order for the traffic to flow in different ways. So what it's essentially saying down here in this section is, it's saying the network administrator has asked you to change the traffic flow. So what we'll do is, and there's numerous different ways we could get this to work, but what we'll be doing is we'll be changing the cost of the links. So we'll be manipulating the cost of the links so that typically if I was going to send traffic between PC1 and PC2, what would happen? Or one would obviously figure out what's the least cost path to get to this network up here. It could either go this route straight up to R2, or what it could do is it could go round to R3 and up then to R2 and then over to this PC. So again, this is done using the shortest path algorithm, Dijkstra's algorithm. So what we'll be doing is we'll be changing or adapting this based on these requirements that it's asking. Obviously, in any task, what we'll do is we'll keep an eye on our score, guys. We obviously want to get 100 out of 100. So in the next video, guys, I'm going to start to walk through this process, jumping in, getting configured on the OSPF on each of the routers. I'll also be adding these router IDs, and then I'll be creating these network statements. And we've got to know a little bit about our subnetting first, and then obviously knowing about our wildcard mask. And like I said before, guys, if you're not sure on this or you need more help, just dive in and have a look at my previous OSPF videos. Okay, guys, we're going to call it there for this particular video. Join me in a couple of moments when we're actually going to get started on the implementation. Okay, guys, thanks for viewing and see you soon.